All right, guys, this is your video over scientific notation. You have a foldable for scientific notation, and this is how you fold it. If you are looking at this page of your paper, you will take the top and fold it down to right above the words that say scientific notation foldable. And then you will take the bottom and fold it right underneath the words scientific notation foldable. All right, so we're gonna do the outside first. We're gonna do these examples first. So scientific notation is this. It takes really large numbers like this and really, really tiny numbers like this decimal here and makes them a little bit easier to read scientifically, as in these numbers here. This is supposed to be a 3, an exponent of 3. So if you can go ahead and take your pencil, and make that into a 3, that would be great. All right, so usually numbers in science are much larger than this. Consider the weight of the earth. It is gonna have a lot of numbers, a lot of zeros at the end of that number. And consider the weight of a speck of dust. It is going to have a ton of zeros like way down the line, and then some numbers down here for that decimal number. Numbers like that are so large to read, scientists have created this term, scientific notation. It makes it easier to read. If you see some exponents, some times 10 to the exponent of a big number, that's how you know that you have a large number. When you see a number written with times 10 to the negative exponent, that's how you know you have a really tiny number. Now, these do not match up completely. We're gonna do examples for these to show you how scientific notation works. I just wanted to tell you that that is what it means, all right? Okay, so big numbers like this number here. Now the commas are only there to help us read. We know place value starts over here. This right here, this number is the ones spot, and I know that because technically this decimal goes here. If this was dollars in your bank account, which would be amazing, the decimal goes here because then I would put my 2 zeros right there for my cents. All right, but we don't have that. We're not talking about money here. We are talking about a really large number that is probably not money. But the commas help us read. They do nothing else but help us read. This is not 100. This is not 100,000. This is not even 100 million. This is 8,600,000,000. That is how we read this word. The commas help us do that, okay? So technically, whenever I am using scientific notation, just know that the commas are only there to help us read, nothing else. Okay, so the scientific notation, you will always see it written like this with a number and then a decimal, a number and then a decimal, okay? Which means that I need to change this into a number and a decimal. The decimal is going to go right here, right after that very first number that I see, like this, 8.6. All right, well, this number is definitely not 8.6. It is 8,600,000,000. So if I write 8.6 times 10, and I'm gonna have an exponent, it's gonna tell me that that is actually this really big number. Here's how you find the exponent. However many times it takes to get that decimal to where I moved it to, that's the exponent that I get here. So I'm going to move this once, 2 times, 3, 4, 5, 6, 7, 8, 9 times to get in between the 8 and the 6 like I wanted it to. So I have 8.6 times 10 to the 9th power. If I had seen this in somewhere in science, scientists will know that this is a really large number. And when they start to rewrite it, they will eventually figure out that it is 8,600,000,000. All right, so let's talk about this little tiny number here. A little small decimal number like this, the decimal is going to have to move right in the middle here. So it is in front or right behind the very first number that you see. Now, since my decimal is here to begin with, I am going to be moving it to the right, all right? I'm still gonna have 3.7 times 10. I'm just gonna have a little exponent up here that's gonna be negative because this is a small number. So I'm gonna go from here to there, all the way to here. Let's see how many times I have to move it. 1, 2, 3, 4, 5, 6, 7 times. So I have a -7 as my exponent. All right, let's try to go backwards this time. Let's try to take scientific notation and make it back into a regular number that we can read. So 5.2 times 10 to the third power. If this was a regular number, kind of like this, I know that this positive exponent is going to make a large number, which means that I need to take this decimal and move it this way so that I can have a lot of zeros behind my number, kind of like I want a lot of zeros in my bank account. All right, so if I take 5.2 and move the decimal 3 times, I'm going to move it once, twice, 3 times. Now, of course, here and here, there was nothing there. I jumped an invisible number. I'm going to fill those in with zeros. So this is my new number, 5200. Let's write it, 5200. And the way that I read this, if I were to use commas, I would read this 5,200. And that is the number. Technically, the decimal is here, but I don't have to write it when you have whole numbers like this. Okay, let's talk about this number. This is going to be a small number because the exponent is negative. So let's take this number here. And I know that because it was negative, it was a really tiny number, which means that I have to take the decimal and move it back to where it began, back to where it started, 4 times. I'm going to move it 1, 2, 3, 4 times. The decimal is going to be right there now. It's not there anymore. And I fill in these little spots that I moved with zeros. So I have 0.00048. Okay, now that we have learned how to do scientific notation, I'm going to open my foldable and do 4 more examples with you. I'm going to do 4 examples, this one, this one, this one, this one. You're going to do the other 4 at Math Workshop. Okay, so let's start with the top one. We are going to take this normal number. We call it this is the standard form of a number. It's just a normal number. And we're going to write it in scientific notation. Now remember, scientific notation kind of looks like this stuff down here. It has this times 10 to the exponent. It also has this number, whatever it is, written with a decimal point here. So I technically would have needed the decimal point to move right there. So I have 4.89. I do include that extra number just because as long as I really need all those extra numbers back behind this decimal. I just need one number in front of the decimal. All right, so this is a big number, which means that a whole number, which means that my decimal is at the end here, just like we write money. We write out money. So we're going to take this decimal and move it in between 4 and 8. So I'm going to move it 1, 2, 3, 4 times. So I write 4.89 times 10 to the 4th. Remember that you don't jump this comma. This comma is not part of the numbers. It is just there to help us read. This was 48,900. This comma did nothing for us besides help us read. Okay? This is the scientific notation of that. Let's take this really tiny number and let's try to write this into scientific notation. So I want to take this decimal and move it in front of the first number that I see, which is 2. This is 0.000216. This is not 0.00016, 216. We don't have 216. We have a decimal number, so we don't use those kind of words. We just say 0.00216. All right, so I now am going to change this to 2.16 times 10 to the I don't know what power. And one thing that I do have to remember is the fact that this is going to be a negative exponent because this is a tiny number. So if I take this decimal and go 1, 2, 3, 4, I have a negative 4 here. This is scientific notation for this number. These 2 are yours to do by yourself before you go to Math Workshop. Okay, now I have 2 scientific notation problems and I am going to try to write them into standard form. Let's try. So 6.25 times 10 to the 8th power, this positive exponent right here tells me that I have a really large number, kind of something like this, right? So I'm gonna have to take this decimal and move it this way. Once I move it this way, it's gonna be at the very end of my number, kind of like this one has here. It's gonna make a really large number for me. So if I take 6.25 and move my decimal 8 times, I'm go 1, 2, 3, 4, 5, 6, 7, 8. My new decimal goes there and I fill in the invisible jumps with zeros. So I now have 6, 2, 5, I have a bunch of zeros. Make sure I got those right, okay? And I'm gonna put commas in here just to help myself read it. This is actually 625 million. That's what this number is. And I don't technically have to write my decimal because this is a whole number. Whole numbers always have a decimal at the end. Okay, let's move on to this one. I can tell that this is gonna be a really tiny number because of this exponent here. This is a negative exponent, which means I'm gonna have a really small decimal. Probably something a lot like this, all right? So I'm gonna take this decimal and move it back where it's supposed to be, kind of like it is here. So I'm gonna just write it over here so I have room. I'm gonna take this and move it 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no, I got way out of my line there. Oh well, I can still figure out what's going on. All right, let me just check to see how many zeros I wrote down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that I can rewrite it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8, 9, 5. That is the number that this was if it weren't written in scientific notation, if it were written in standard form. These two are your next two example problems to do on your own before you get to math workshop.